I want you to know about it. It's up to you if you want to use it. So I covered the sign of the derivative. I don't have it. I determined the critical numbers. I put them in. I found the corresponding y value for those critical numbers. And I have the second derivative, and I study the sign of the second derivative. And then I'll tell you why I'm not using this method myself. And let's also say that at this point, we want to identify what type of point is negative 354. Negative 354, keeping in mind that this is the shape of the graph. What can negative 354, looking at the second derivative, what can negative 354 be? What type of point?
Negative.
What type of point? The
Is it
function.
the inflection point?
We're not talking about 0, 0. We're talking about somewhere in this interval, there is a critical number, negative 3, and the point is negative 354. The function looks like this. It has to be a maximum, right? I don't have the sign of the first derivative, that's why I covered it. But if the function looks like this and there is a critical number somewhere, this can not be anything else but the relative max, because the function looks like this. Let's look at the other one. There is a critical number and there is a critical point, 3, negative 54, and the function looks like this. In that territory, in the territory where the second derivative is positive, what type of point can 3, negative 54 be? For sure. Yes, of course. So if the function opens up and there is a critical number in that area where it opens up, this cannot be anything else but a relative min. So what is the moral? And I will put it in writing. What does this say? It says that if I'm lazy and I don't want to find the sign of the derivative, of the first derivative, that I can figure out the sign by the fact that there is a critical number here. The function opens up, so this must be negative positive. So see, everything is related. If it opens up and it has a critical number, the signs have to be negative positive for the first derivative. If it has a relative minimum, a relative maximum, because it opens down, then the signs have to be positive, negative, because that's the only way for a maximum for the first derivative. That is the second derivative test. So if there is a critical number and the function opens downward, this must be a max, and you can put the signs in. I don't use this method. Here's why. If I cannot determine the sign of the first derivative, chances are that it's so much more difficult to find the signs of the second derivative. I still have to find them. But why would I go back instead of making sure that these two rows work well together? If they don't work well together, by the time I get to the second derivative, I have huge errors, potentially. So it's up to you. You can determine the sign of the first derivative from the sign of the second derivative when there is a critical number. So that's another option. So in short, let me just write what I just said. If C is a critical number and F double prime is positive, if C is a critical number and F double prime is positive, that is a relative minimum. C gives a relative min. So this is like a note if you want. It's the second derivative test. The same thing. If C is a critical number and the second derivative is less than 0, then of course C gives a relative max. Do I need this? No. I don't need it if you follow these steps. You find the sign of the first derivative and the sequence of steps that we presented today. If you want to use it, it means that you will determine the sign of the first derivative based on this. That's up to you. Okay, I would like to work on a problem similar with the one we started today. So let's choose. And this is very good exercise to learn the table. So if you'd like to choose, so these appear really gibberish, real gibberish here. If I don't summarize all this, I will never be able to come up with a graph. So if you want to choose one of these, and then we'll look at a word problem so we can move on.
36.
Which one? 36? You said 36?
Yes.
Okay, let me copy 36 and then I'll stop sharing. So 36. We have f prime of -1 is 0. F double prime of -1 is greater than 0. F of -1 is -5. Okay, now it's moving to 7. Okay, f prime of 7 is 0. F double prime of 7 is less than 0. F of 7 is 10. Okay, it's moving now to 3. Okay, f double prime of 3 is 0. And f of 3 is 2. Okay, I'm checking to make sure I copied everything. Double prime of -1 greater than 0, yes. F of -1, -5, yes. 7, yes. Prime, yes. Double prime at 7, f of 7 is 10, f double prime, okay, 0, and f of 3 is 2. Fine. Good. Perfect pick. This exercise, again, will help us understand the table. This is gibberish to me. Like a foreign language. I don't understand any of this. Doesn't tell me anything. I just need to plug in my computer. Sorry, just 1 second. Okay. It's running out of juice. Okay, good. So now we are going to make sense of all this gibberish. It's a mess, right? I'm not saying anything else, but a very good pick. Thank you. So here's my table. The first derivative, the function, and the second derivative. I'm going to cross them out. Don't cross them out. I'm just trying to make a point. Okay. So I'll start with the function. F of -1 is -5. F of 7 is 10. F of 3 is 2. I continue with the first derivative, of course. So let's see. F prime of -1 is 0, which tells me that this is a critical number. F prime of 7 is 0. That's another critical number. Finish with the first derivative. Now I'm looking at the second derivative. The second derivative at -1 is positive, which means the function looks like this, which means immediately what type of point is -1, -5? It's
relative minimum.
Yes, it's a critical number, and the function, the second derivative is this. It's positive, so it has to open up. So this is a relative min. The second derivative at 7 is less than 0, which I know it must look like this. What type of point is 7, 10?
Local max.
Relative or local max. Finally, the second derivative at 3 is 0. So see, this is a perfect example in which the analogy that we just looked at is important as an example of graphing a function. Okay. The second derivative here is positive, and the second derivative here is negative. What type of point is 3, 2, and the second derivative is 0 or undefined? What type of point is 3, 2? Exactly. So from this, which told me nothing, what is this? I mean, how can I imagine all this? There is nothing that tells me anything here. Look at this. Completely clear. And now I can graph. There are infinitely many correct answers, of course. I will start with the points, like we always do. -1, -5. I don't think that this is a good color. 3, 2. And 7, 10. 4, 5, 6, 7, 2, 3, 4, 5, 6, 7, 8, 9, 10. A relative minimum. Increasing to, holding water to the inflection point. Changing concavity. Reaching a relative max. And it's done. I don't have to do anything else. So this is the importance of the table. Let's look at a word problem now, see what they want with these word problems. Oh, I didn't mean to change the page. I meant to go up. Okay. So labor force, sales saturation. Okay. We're not going to graph. This is way, the numbers, the coefficients are, no. We are going to graph things that we can graph easily. This is, no. This can be done with a graphing calculator. And it tells us to graph between 0 and 30. But what I'm interested in is find the point of inflection. Yes, that is important. And interpret its meaning in terms of the rate of change in sales. So what happens at the inflection point, see, the second derivative, the first derivative is increasing, right? Huge negative, 0, up, 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 up. So the rate of change is increasing till the inflection point when the function holds water. But now the derivative, look what happens to it. It's decreasing. Huge positive, smaller positive, 0, negative. So when the function is concave down, the rate of change, which is the first derivative, is decreasing. When the function is concave up, the rate of change is increasing. So let's choose a problem and just determine the inflection point. Okay, so let's look at 41. Here it's asking for the highest, which is the first derivative. But here it's we're talking about the point of inflection, so obviously we are talking about the second derivative. That's all we need to remember. So in 41, I just copy the function. So s of x, -0.0131 x to the third plus 0.0131 661x squared minus 2.021x plus 6.865. Okay. Okay, so S is in millions and X is in month. Okay, X month and S millions. Millions of dollars. Good. So in order to find inflection point, what are my steps? What do I have to do first?